Okay. Looks like we're at the top of the hour. It's midnight on the U.S. East Coast, wherever you are. Welcome to Dnsop at IETF 109. We are going to do what we've become accustomed to doing with Meet Echo. Tim will be going through the chair slides, what we've done since the last IETF. And then we have a bunch of drafts, progress on already adopted drafts and potential new work for the working group. So let's go ahead and get started. We will remind you at the top of the meeting that this is being recorded. And there's a bunch of other administrivia that's in the chair slides. So Tim, if you're ready, we can go ahead and get started.
I am ready. So good morning, all. Let's
morning,
jump to the next slide. Yes.
Yeah, good morning, good afternoon, and good evening.
And good evening. So let's go to the next slide. And welcome to Dnsop. Benno is not here today. Benno is down sick. So he has managed to sort of catch the COVID. So we hope he gets better soon. So he contacted us the other day and said he wasn't gonna be able to make it. So it'll be Suzanne and I. So she'll be working on that. And as we go to the next slide, there'll be the note well about everybody, following all the IATF processes and guidelines and stuff, and all the nice things for that. And if we go to the next slide, you can sort of slide through these. Our agenda is pretty straightforward. We've got some updates on the old work. We've got some that going on now, some current business and some new business. And we did a little bad math, so we're going to run through the chair stuff pretty quickly, but you all should, can read the slides as well. So as we go through the document updates, next, since our last meeting, we've had 4 things become RFCs, which is pretty great. No response, multi-provider DNSSEC, extended error, and 2845 biz, which actually is in auth 48, I realized at the last minute, but I believe that should be all sort of taken care of. The authors are sort of finishing up the final edits there. So I may have jumped the gun on that one, but that's been pretty great. So congrats on everybody. Yep, let's go to the next slide. Yep. We have 2 more things in the ISG queue, Zone Digest and Server Cookies. Server Cookies just went through working group last call. And one of them we're rating the write-up, which actually passed working group last call, and Benno was working on the write-up, but that'll probably be delayed a little bit as he sort of gets better on the Yang stuff. So we still have some more stuff moving forward. So as we go to the next slide, in working group last call, 7816 biz, actually, I believe this probably is finished passing. I just need to send out an email to sort of say that. I know there's some updates to the documents. Mr. Hoffman has a, oh shoot, I accidentally removed you from the queue, Paul, so can you do that again? I'd like you to sort of speak, yeah. How can I, and why can't I let you speak? Please go ahead.
I think I can speak.
Yeah, go ahead.
The authors of 7816 BIS, we are looking at we got a bunch of good comments. The editorial ones are already in our internal repo, but there are actually some technical changes that people asked for. So we haven't done a new draft, and we also haven't discussed, once we do a new draft, if we're going to want a second working group last call. Yeah. A couple of people had asked for some changes, which I think are technical enough where we might want review, especially from implementers. But it's not clear. The document authors are chatting with each other, but it absolutely is not ready to move forward yet.
Okay. So
yeah, thanks for that. We'll look for that as it goes through. We want everybody to be satisfied with it before we go ahead and advance it.
And I'm not sure. Okay, yeah. And so thanks, Paul. And we can take a look. It looks like it's normative type changes. We should do that. There's a couple documents that I feel are pretty much ready for working group class call. The the HTTP Service B, the Service B draft. They've done a lot of great work on that. And I've seen some good implementations. And so barring anything, I'm thinking we'll probably do that in December after the holidays, after the American holidays. And also TCP requirements, which we've been sort of sitting on and waiting to sort of do that. And we should probably just do that. And moving on to the next slide, I believe there's a couple other documents that are, we've got, oh yes. So on the open calls for adoption, 8499 biz, we got some feedback from Tony and a few other people on some stuff. And I believe that adoption looks done, Paul, so we can adopt that. Merge in some of the terminology comments that we wanted to add, as well as some language stuff, and sort of get that sort of rolling along. And I'll send out a note on that this week as well. So if we go to the next slide, I know we have, oh yeah, mostly what we can skip one. Yep, and everything's sort of sitting in our data tracker and also the GitHub. We have probably also a dozen documents that have been adopted, and spending some time looking at them this weekend, there's a few of them that I think are getting very close to working group last call as well. A few of them being discussed today, and especially like the NS revalidation draft. The delegation only is interesting. The fragmentation draft. I think some of these are getting really close to getting working group last call. And so I believe what we'll do is the chairs will probably start focusing on some of these to start moving along. And there's a couple of small ones, like the glue is on optional, that as well, like Mark's draft, that's pretty straightforward, that I think that's been adopted, that we should probably also sort of pack up and move along. So that's, I don't want to let too many things sort of sit, but we do have a lot of stuff going on. All right, next slide. I think what we've got here is the agenda. So Shuman's going to talk about NS revalidation. Dimitri's going to give his 5933 biz update. There's Roy's going to talk about the private use TLD. Mr. Fujiwara-san's going to talk about avoid fragmentation. And then on the next slide is some of the new business, which is Paul's IANA consideration draft, which kind of ties into the 5933 biz. It's sort of a, discussion on changing the registry. And I know we talked about this before, and there was some strong pro and con sort of thing. And Anu's got IP range location, and Ray's got the Dnsop error page draft. These are some new things that are coming out. So we'll kind of move things along, and we'll jump straight to Shuman.
Yeah, let's go ahead and get started.
And get started. So thanks all. And any other questions, just sort of speak up.
All right.
Hey folks, can you hear me okay?
Sir.
There we go. And let me just adjust the size so we can look at one slide at a time. There we go. There.
Okay, I guess that's good enough.
Yep. Sorry about that.
Yep.
No
problem. All right, so thank you, Suzanne and Tim. So I'm going to give an update on the delegation revalidation draft. So if you can advance to the next slide.
Yep. There we go.
All right, so some quick background if you haven't paid attention to this. We first presented this draft at the IETF, I guess it was the IETF virtual in April 2020. So that was a replacement for the canceled IETF 107. And I provided a link to the slides here. It was subsequently adopted by the working group in June. And there's a link to the current version of the draft. And briefly, to remind folks, the two main recommendations are, the first is upgrading NSRR set credibility. That means resolvers should deterministically obtain the child NS set and place it preferentially in their cache. And the second part is that they should also revalidate the delegation at most at the expiration of the TTL of the parent side NSRR set. So you can move to the next slide.
Yeah.
We pushed out a new revision of the draft, I think a few weeks ago, and I'll summarize the main update. So I think all of these updates have been discussed on the list or at a previous ITF meeting, so there shouldn't be anything really surprising in there. So of course we renamed the document as a working group doc. It's currently at revision 00. We expanded the motivation in the intro section a bit. We made some minor adjustments to make the revalidation algorithm description fully compatible with QNAME minimization. And for the discussion around the DSTTL, we split that out into its own section, where we mentioned that although by spec, specifically RFC 4035 section 2.4, the DS and the delegating NSTTL are supposed to match. In practice, they often don't and typically don't. So one possible proposal is that resolvers should use the DSTTL, which is, of course, signed as the revalidation interval itself. So I think folks made this recommendation in the past, but I'm not sure we had consensus on it. So this probably needs some more discussion. Right now in the document, we say resolvers may, that's uppercase may, do it. So the question is, should that be promoted to should, or should something else be said or done here? So that's one of the questions that we have. And then if the entire NS set is assessed to be lame, then the resolver should perform revalidation of the parent, but with a hold down timer to avoid inadvertently spinning and inflicting a denial of service loop at the parent zone. So we don't yet specify a value for the hold down, and we probably should recommend something here. So I think Paul and some other folks have an idea what it should be, but that's maybe that should be something we should collectively discuss. So let's move on to the next slide, Susan. There is a new section on optimizations where we've added some of the possibilities that have been discussed previously on the list. And they are that resolvers can cache whether authority servers are doing minimal responses or not, and use that information to subsequently forego the additional child NS query for those that that don't. And secondly, authoritative servers that are performing minimal responses could also help out a bit by selectively adding the authoritative NS set in their responses only for the DNS key queries. So they're minimizing every other response except for the DNS key query. And this might allow resolvers to cache that information and similarly forego the additional child NS query for subsequent interactions with that zone. So these are currently just mentioned as possibilities without any strong recommendations either way. So that's another open question about how strongly or not we want to recommend that resolvers do these things. And lastly, there's a new section on delegation changes. So things like removal of delegations and redelegations of the zone to new name servers. So this section says that if the delegation has been removed, ideally the resolvers should prune the cache at the delegation point as specified in RFC 8020. Or if that can't be done, allow cached entries below the zone cut to persist until they expire. And if only a subset of NS servers have been redelegated, then no cache cleanup is needed or desired. Next slide, that may be the
Yeah, that's
right.
that's it.
Okay, yeah. So that's basically it. That's a summary of what's changed in the latest version of the draft, and I'll open it up for discussion.
Comments, questions, recommendations for how to resolve some of these issues.
Ralph?
So I still feel very strongly about this, and I still don't think that we should do this work, as I said, when we had the call for adoption. It is wandering way too far into implementation territory, and it forces away how certain people think how the resolution process works to be kind of implemented by all resolvers. There are other ways to do resolution, and there's other ways to handle delegation. It also makes some assumption that sort of the cache that you have for records and for delegation is the same. That's not always the case. Everything that we do that causes outbound queries on a resolver will be abused. And this is one thing that certainly will be abused. So it is the minimize question also is something that really, even if other resolvers, if authoritative would send the stuff back, it depends on the resolver if he takes it or not. So I think we're having some bad assumptions, or we are trying to implement something that might help one or two use cases, but that overall will kind of make the way how resolvers over the internet behave more consistent and more abusable. So I'm sort of very much still opposed to that work.
Yeah, so I understand, Ralph, your position, and I know some people disagree, but on balance, the consensus went the other way, right? So.
Any other?
Brian?
Hi. I'm sorry, I was a little bit late joining. I wasn't sure if any of this has taken into consideration some of the new things in EDE, extended DNS errors. I know for sure, like we at GoDaddy have implemented and are using the non-authoritative extended error 20, and I think that might be useful and helpful for anybody who wants, or any delegation check against an authoritative server to find out if it's lame. If the server you're asking thinks it's not authoritative, that I think is going to dovetail very nicely into this. Anyway, that's just an observation. I don't know if it was raised at all at any point.
No, it hasn't been discussed. So can you remind us what the extended error code 20 is used for?
It basically says, it explains why you're giving an answer that says refused. And it specifically says, right, I'm refused because I'm not authoritative.
Got it. Yeah. Yeah, I mean, so certainly resolvers could use that information to determine more precisely that a delegated server is lame, right? So
yes,
I think that would be a reasonable thing to do.
Yeah. Because right now there's no feedback loop to the delegation parent. If you're not authoritative, there's no mechanism for you to, and you're not the registrar. You have no method, no channel back to say, hey, this is broken.
Yep.
Which is why we
Agreed.
need this draft. Okay.
Okay. Paul, you have your hand up, I think.
I do. As the note taker, I would appreciate if people, either you, Tim, would give full names or people would use their names. I recognize many people by their voices, but not everybody. And I've noticed that not everyone's using their camera. So do the equivalent of flashing your name badge to me by at least vocally saying who you are. Thanks.
Okay, next. Yep, good. Thank you, Paul. That's a good point. And Dizago, you said...
Sorry about that.
There's one other person with their microphone unmuted. I wasn't sure if they wanted to speak or not. Okay, so I believe that's covered everybody. So, okay. Good. Well, thanks, Shuman. I think that kind of covers it. That was we're getting closer sort of thing.
Yes, thank you.
Thanks.
Yeah.
And certainly anybody who hasn't read this draft lately and might have some opinions on how to resolve these issues, go reread it and comment on the mailing list, please, because we do need the input so that the authors can resolve those last open issues.
Yep. Now
Hello?
Dimitri's up. Yep.
Hello, can you hear me?
Yes.
Yes, we hear you.
Okay. So my presentation is very brief, in fact. Could you please switch to the next slide?
Yep. There you go.
So the draft is dedicated to introducing actual Russian Ghost standard to DNSSEC. After a long discussion, draft was adopted by the working group in summer. There were 2 or 3 reviews which did not touch the text of the draft significantly, and the only point that was clarified is the relationship between the draft and the RFC 5933. So the text of the document is stable. It differs from RFC 5933 mostly in the part of examples. We have an implementation. I have an implementation in LDNS project. Here is the link. And well, in fact, any OpenSSL-based DNSSEC implementation can be easily extended to implement the draft. Also, we have optimized the open source implementation of the elliptic curves used in the draft. So we, in fact, have the speed comparable to the curve 25519. Well, in these circumstances, I think it's time to ask for the group last call. If anybody is ready to review it again, of course, we'll take into account the proper changes, questions, and recommendations, but the text is stable enough. Does not call much interest, in fact, because Ghost is subject of low interest outside of Russia. So that's all. Thanks.
Okay, Peter.
Hello, this is Peter van Dijk at Power DNS. 2 questions, 2 things. One, as Ghost is very Russia specific, I'm not sure we would implement. But if we would really like some test vectors in the draft. Can you do that?
There are test vectors in the draft.
Did I miss them?
I think you did.
Let's see. I see an example DS.
And the example of the signature and example of the key and the signature are present too.
Okay. Well, I will have another look then. Thank you.
Not a problem at all.
You're right. I see it. Yeah. Thanks.
Okay. Thanks. Jim? Jim, are you there? Yep. And we don't hear you, sir.
Still not hearing Jim.
Oh, he's...
Don't quite understand this implementation. Just a question on the status of the Ghost crypto code. Is that widely deployed in things like OpenSSL and other crypto libraries?
actively participating in OpenSSL. So Ghost is, of course, implemented in OpenSSL. I'm aware of implementation of this standard in GNU-TLS, and Ghost algorithms verification are included at least in Linux kernel.
Okay, thanks.
Okay, Paul?
So just saying this for the record, but I don't want to see this adopted for working group last call until we figure out whether it would be on standards tracker for informational, but we'll be talking about, or I'll be talking about that in a few minutes in my draft. Other than that, I think it's fine. That is, technically it seems fine. I'm not an implementer, so I don't know whether between this draft and the RFC that describes the actual signing algorithm, if it's implementable. I sort of assume it is, that, you know, somebody who's not Dimitri probably could do it, but it would be interesting to hear from other people, although that's not really a requirement. But seriously, the only thing I have on this is whether this would be for standards track or not. And I would say we should wait before working group last call to determine that. Thanks.
Okay.
Thanks, Dimitri.
Thank you.
I think Roy's up
Okay.
with another good time for everybody. So, Roy, there you are.
Good morning, everybody. Hope I'm clear. First off, thanks to the Dnsop working group chairs for number one, adoption, number two, for allowing me to talk a little bit about this. So I'll first talk about what happened since it got adopted. Next slide, please. Or can I do that myself?
No, I have it. We've discovered switching between speakers and controllers for the screen is a little bit awkward, so we're just doing it. Mm-hmm.
Oh, wonderful! Thank you, Suzanne. So first off, I hope Benno recovers quickly, of course. Wish he was here. Secondly, what changed since the adoption? Well, the authors have changed. They became editors instead of authors. That's the way I see it, which means that we live at the will of the working group. Ed Lewis, who was the very first author of the very first draft, decided to move on to bigger and better things. He's very, very busy with other stuff, and so I've asked some help from people who offered. Number one, Joe Abley is a good sense of what is needed. Very good technical writer as well, and additionally, Dr. Eberhard Lisse. Dr. Eberhard Lisse is well known in the ICANN world. He's part of the CCNSO. He's the CCNSO tech. Sorry, he's the tech working group chair. So he has very good experience with all things ICANN, the way I see it. So he's an editor of the draft as well. So just to recap, what is the draft ARIN's private top-level domain said at the time? Designate ISO 3166-1 Alpha 2 user-assigned code elements as top-level domains. So they can be used in, it says as, but it means in private space networks. And so these elements are used like, are used as is by other standards organizations as well. And they're unlikely to be reassigned by the ISO and unlikely to be delegated by ICANN. Now, keep in mind, this was the draft that was adopted at the time. So we had lots of discussions on the list, and they're basically the way I see it, and I'm sure that people line up on the mic to remind me of yet other things. Two main points of contention. One is private namespace is basically a bad idea. If you want to have something like that, use a registered name instead. And the other thing is namespace policies are not ours to make. That lies elsewhere. All right. Next slide, please.
Yep.
Sorry, Suzanne.
No problem. Just multitasking. You know how it goes.
Thank you. All right. Here's what the editors propose to the working group. Number one is refrain from discussing private names or namespaces as a solution for anything. I've realized that this is a big can of worms. And also, if we need a document that talks about a private namespace, problem space, the concepts, the purpose, the facilities, the setup, the need, etc., or even the best current practice around, and I'm calling these independent names to avoid private namespaces just for a second. That's actually a different document than this is. What I sent to the list the other day is maybe we need two documents. One document that talks about private names, and another document that proposes what a private namespace could be. So that's one proposal to the working group. The other proposal to the working group is to change the tone slightly in the document, is to observe and recognize that these ISO 3166-1 Alpha 2 user-assigned code elements are used as intended, right, by many different organizations in many different ways. And the intention from the ISO has always been locally defined and locally meaningful to those organizations that use them. Excuse me. Another thing that we've come across is that these code elements as top-level domains are actually used in the wild. And this has been clear to us in the DNS magnitude study from Alexander Meyerhoven, who's also a participant here in the working group. But Alexander Meyerhoven has done a DNS magnitude study, which he will actually publish, I hope, next week, Thursday, at the Center R&D working group. So that's not available right now, but I'm sure that when he releases it, I will make the working group aware of this. So these ISO code elements are actually used currently. So with that in mind, next slide, please. Thank you, Suzanne. There we go. With that in mind, I'd like to, and this is actually a proposal from Joe, and it's not the worst one I've heard from him. So this is a proposal from Joe. This is follow the spirit of basically obsoleting a code element in an IANA registry. I realize that this is slightly different than actually obsoleting a code element, because we're talking about namespaces here. But for instance, if you look at RR type 254, 32769, opcode 1, and EDNS option 4, etc., those are code elements that have been retired. I want to avoid the use of the term retired, because retiring a top-level domain has a different connotation, for instance, in the CCNSO working group. Sorry, in the CCNSO ICANN workspace. So that's why I name it obsoleting. I think that's the correct term to use here. Well, that implies actually the spirit of obsoleting, that these code elements cannot be considered as potential top-level domains in the root zone. And I know I'm stepping on policy toes here, and this is not an actually. I think this is not an explicit policy that we can make, unless we use something like RC 6761, but it does follow the ISO's intent and the policy that was is one of the founding documents of the way I see it. ICANN RC 51, sorry, IANA 5191, sorry 1591. So with these, let's call them baby steps going forward on the tone of the draft. I would like to hand the microphone back to Suzanne, and if people want to ask questions, I'm here for it. Joe is here as well. Dr. Ebadlis is here as well. Thanks, everyone.
Thanks, Roy. It looks like Ted is in the queue.
Or was in the queue.
Howdy. Thanks very much for laying out the draft. Roy, I had the chance to read it a couple of weeks ago, and I confess that some of what you've put forward in today's meeting kind of echoes some of the things I was thinking about it. In particular, you mentioned a possibility of splitting the draft into two things, one of which talked about private use names and had that whole can of worm. and one of which talked about this particular set of names. And I like that idea for two reasons. One, I think it is absolutely required to get a good use of what that sort of locally significant means when we're talking about the DNS and not in terms of the other ways in which ISO may have meant that when setting these aside. And the second is, I kind of feel like that document that's talking about these specific names should actually be an ISO document talking to ICANN, not an IETF document. And I think it would be valuable, but I don't think it actually comes from us, because what this document is trying to do is to go from ISO being unlikely to reuse those to making it essentially impossible. And because this is something that is really kind of their bailiwick, I would be very happy if they said, we will make this impossible, and therefore we confirm to you, ICANN, that this usage of these names is consonant with our policy and intent. But I'm somewhat concerned that without ISO saying that to ICANN, the IETF saying it to ICANN based on some possibly revisable policy of ISO's is not right. And so I was wondering, have you guys talked to ISO about this? Would they be ready to send such a document to ICANN? And if they were not ready to send such a document to ICANN, what were their objections? Thanks.
Roy or Joe?
I'm not very good at Meteco, so I have no idea really how this works. So
No, you're on. You're good.
Very good. So the idea with this was, I get the point that this is potentially a very policy minefield that we're wandering into in this document. And so first of all, the studying the documents was really identifying there's two orthogonal cans of worms here. Let's have separate cans because they're different kinds of worms. And I do think that's a good idea, and it's good to hear support for that. The can that contains the two-letter codes, the idea really was to try and limit the scope of the discussion in the IETF to just the things that the IETF has something to say about, which we thought was just the fact we have code points, we have the DNS, we have elements of all of this that are very much IETF territory, and we have an observation that these things have been used before, and that we can effectively expect name collisions if these things were to appear actually in the root zone, because we know they're being used for other purposes. So it was really, the purpose of it was really to document that. And the hook that we have and the tradition that we have in the IETF is to take code points that have been used for some reason in the past and note that they've been used in the past and note there might be a conflict from using them in the future for a particular purpose. And this is why we don't have an IPv5. So the idea of all of this was really to limit the scope to just the stuff that the IETF has something to say about and not anything else. And in particular, by basing it on an observation of what's happened based on historic 3166 policy and historic operational behavior that's based on that, we don't actually need to link in the future. All we need to do is make the observation this has happened in the past. And because it's happened in the past, this constrains our use.
Can anyone hear me?
I can hear you, Roy.
Oh, sorry about that. Sorry, go ahead, Joe. My microphone wasn't working for a second, so go ahead.
Joe, you're still up.
Do I have to de-up? I finished. I have nothing else to say.
You can turn on video.
Okay.
We can
Okay,
go
so-
ahead and
Can I just, sorry guys, can I just add one more thing to
Sure.
what Ted said? With regards to the ISO, I didn't fully hear Joe's response because my headset was playing up. All right, I admit my battery died, but anyway. So regards to ISO, ICANN, and IETF, I think if I look at this Venn diagram, I think the ISO has already said since the inception of the standard 3166 that these names are reserved locally, and that organizations can use them in their own way. The ICANN has basically followed RC 1591 on this, adopting the ISO's policy. Now, that doesn't explicitly mean that these strings can be used. But I think if you look at this as a Venn diagram, there needs to be an overlap between ICANN, IETF, and ISO, where all three explicitly say that, yes, these can be used for something local. And I think the ISO has done that. The ICANN is busy with it. They also need to answer to ESSEC 113, the ICANN board. And I think that the IETF in itself also needs to do that. And that's what this draft is trying to do.
Okay. So Brian?
Just to kind of put a different viewpoint on it is, I think what the document's saying and what reality says is, ICANN says two-letter space belongs to ISO. ISO says these names are not used and will never be used for anything real. And all we need to do from the IETF perspective is say, IETF is not going to do anything with these per se. So everybody's in agreement that this is space that is never going to be used from the perspective of what's already been said. I don't think anything much more than that needs to be actually said.
So can I respond to that really quick? I completely agree, but there are some folks, and I don't disagree with them. There are some folks that said that's all good that all these organizations have these good intentions, but let's make it explicit, because we don't know what these organizations will do in the future. And so there are folks that agree with you, and there are folks that want a little bit more than just agree with you. They want something explicit.
Cool. Thanks, Roy. Warren?
Thank you, Warren Kamari. So both Roy and Joe mentioned policy implications, and I think it was Roy also mentioned SAC 113. Just so folks know, Joran, the CEO of ICANN, sent over a liaison statement a while ago. I will paste the link to it, largely saying, we have this document from ICANN SAC saying that, possibly recommending that a name should be reserved, and then a response from the IETF, or actually, sorry, from the IAB and IESG, largely saying, yes, we agree with what you said. I'll actually put the whole text in, it makes much more sense. But the important thing at the bottom is, we think it would be useful to engage IETF and ICANN experts in a dialogue on this topic, and we'll follow up to try and get that arranged. And that's mainly referring to the special use names problem statement and the sort of lack of clarity that we all know exists in 67, 61, and sort of who does which bits, etc. So figured I would mention that. And as I say, I will put links to the letter from Joran and the liaison response, none of which is surprising. The questions were, I think, very reasonable, and the response largely sort of nods and agrees.
Thanks, Warren. Jim? Are you muted again, Jim?
Still not hearing Jim. You want to go ahead in the queue, Tim? We should probably close the.
Yeah.
We should probably close the mic. At
We'll
this
close it.
point.
Yeah, we'll close it after Stuart. So,
Yeah.
Mr. Hardy.
To Joe and to Roy for continuing to be so careful in their explanations of what's going on here. I do, however, feel like there are two pieces of this that we still need to be more careful about than the draft is right now. And one is there's a very serious distinction between ISO's intent to say that these are reserved and we don't intend to use them as country names, but they might be used for other things. And the conclusion that they should be used in private use DNS in the way this draft imagines. So I think Joe asked in the chat, what should 01 say? I think, as before, the right thing to do is to take up, what does it mean to have this style of name in one document? So split that out, and in the other one, to go back to what Roy was saying, to say these are being squatted on, and to say flat out, not that we recommend you do that, not that we think it ought to happen, but that we observe in the wild that this is happening. And if you say that, I think it's uncontroversial. You probably have data to back it up. And with that, you're not making a recommendation that they be treated according to any particular future use. You go back to what Roy was saying, this is what we see in the wild. And I think that allows you to go, after you've developed the document you split out, back into that policy process and say, hey, now we think we have a good idea of what these can be used for as non-general purpose DNS names, but as these kind of particular class of special use names. And that allows you to make sure that ISO and ICANN and the IETF are in fact all in agreement on that particular use of these names. I think at the moment, relying on ISO having said that these are reserved and seeing them in the wild and drawing the conclusion that therefore they can be used in the way that they are in the wild is probably not as clean as I would like it to be. And I think splitting it out and shifting that tone would help a lot. Thanks very much.
Well, thanks, Ted. Eberhard?
Good morning. Can you hear me?
Yes.
Okay. This is my first IETF meeting, so bear with me. I'm an actual newbie in these things. I've been vice chairing the retirement policy development group at the CCNSO. What would happen if a country ceases to exist or something, or splits apart? That has led me to do really detailed study of the ISO standard, which has recently been written. In the beginning of this process of this particular document, I was a bit concerned, but I've changed my mind because, and it is very helpful what has been said by several participants to split this into two. The ISO, which is a UN type organization that meets occasionally and is not really that predictable, has been predictable in that it says there are a certain number of code elements, character code elements that are not part of the standard. They're not reserved, they're not part of the standard. And then there is a list of 32 or something. The point here is that there will always be 2 letter code elements that are not part of the standard. They are reserved in quotes because there are entities that need those to do things, and they even reflect this in the new standard in the bibliography, where they say these are uses where this is being used for. In the same bibliography, they also mention IANA function, the public term technical identifiers, and so on. So my view is that it will never happen that they do away with all of them, and it is extremely unlikely. It's much less likely than a plane flies on the house, lands in the house that I'm living in at the moment, that any one of the ones that are currently there are being changed. I don't see this ever happening. I don't know whether this is good enough engineering standard, but I would, for my own personal belief, I would think so. So it does make sense to split this into two parts, and say the ones that are unassigned should never form part of the root, and then one can look at the ones, which ones are unassigned in a separate document. Thanks.
Stuart?
Hey, can you hear me?
Yes.
Yes.
Good. I added myself to the queue just because I heard a comment and I didn't catch who was speaking. And if I heard it right, the comment was along the lines that there are certain codes that ISO said they won't use and ICANN says they won't use, and the IETF should say that we won't define anything about that either, and they're free for local use. And the problem with that is whenever you say something is reserved, inevitably a whole bunch of people leap forward and think that means it's reserved for them. I've even thought about writing a draft with the title, "This field is reserved, but not for you." The problem is if you don't say who it's reserved for, then my ISP might decide to use .zz for their private stuff. And I might buy a bunch of IP-based home automation technology that in my home says we can use .zz because it's reserved for local use. And my company uses .zz and I connect over VPN, and now we've got 3 different local uses that conflict. So my comment is, it can often seem very tempting to just say, this is reserved, do what you like. But I think the IETF is abdicating its responsibility if it says that, because then you get conflicting uses. And the mission statement to the IETF is to help maintain a well-functioning internet. So I think we can't abdicate that responsibility. If something is reserved for a purpose, we need to be very clear what purpose it's reserved for. That's it.
Okay.
Thanks. Jim, do you want to try again? And then we'll let Warren have the last word.
Is this working for me now?
Yes.
It is.
Excellent. Sorry, guys, it's far too early in the morning for me. My comment relates to the text in section 4 of the document. Roy's got a fairly comprehensive list of all the different organizations and agencies that are doing things with these special purpose ISO 3166 codes. I think this material is inappropriate for an RSC because it's not up to the IETF to document what the International Civil Aviation Organization or the World Bank chooses to do. I think that's completely inappropriate. And of course, those organizations' behavior and policies could change. You know, maybe they're using .xn today, but maybe they'll change, they'll use .xu tomorrow. So I don't think this material is relevant to an RSC. It's useful background information, but I don't think it's at all appropriate to go into an RSC. Thanks.
Jim, this is Roy. I think you're right. What I'm going to propose is to move that section to an appendix and basically say at the time of writing, this is an example, this is a non-normative list, etc. All the stuff there to just make this anecdotal and not part of the actual content of the document.
Yeah, thanks, Ryan. I think you could only use 1 or 2 examples. I don't think you need to enumerate everything in that appendix. Cheers.
Yeah. All right.
Okay, Warren and Brian, we've closed the queue. So Warren's got the last word as AD, basically. Sorry about that.
Thank you. I'll try to keep it short. So I think that Ted and Stuart kind of hit the nail on where my concern with this is. Throughout the presentation, people have said things like, you know, it's extremely unlikely that these would ever be taken off the reserved list and used for something else. And so that's where my concern is. If ISO were ever to try and say, .zz is now going to be reassigned for Zanzibar, unlike with many other uses, if we started using it in the DNS, that really makes it very hard because of the sort of uncoordinated use of this, it makes it really hard to take it out of that. Once people start using .zz for whatever internal use, you can't figure out where it is, you can't remove it, basically the name collisions problem. If we had something from ISO saying, no, seriously, these ones that we're saying you can use internally for private type stuff, you can use them, no worries, we will never reassign them for anything else, then I think this is a grand idea. My concern comes from what happens when ISO tries to reuse it and then the IETF has to say, oh, sorry, yeah, we trusted your earlier document, and now you kind of can't do that. Hopefully that wasn't too rambling.
It does give you the last word, Lauren. And we will continue the discussion on the list of how this should be moved forward. And I guess we should go on to the next. Who is our next presenter?
Mr. Fujiwara-san with the avoid fragmentation.
Yes, and that will be up just in a moment. There we go. Okay, please go ahead.
Can you hear me?
Yes.
Okay. This is Kazunori Fujiwara from JPRS. I will talk about direct IETF Dnsop avoid fragmentation. Fragmentation avoidance in DNS. Next slide, please.
There you go.
These are updates from previous IETF meetings. Co-authors submitted 02 version this September 15. Differences is here, and these are differences from previous version. We simplified recommendations in section 3. Details are described in next slide, and we added text in section 4. Default passMT value for IP version 4 is XXXX. Default passMT value for IP version 4 is XXXX. Discussion under here will be deleted when the discussion is over. Next slide, please. These are current recommendations. Section 3.2 recommendations for UDP responders. UDP responders should send DNS responses with IP.flag, IPv6.flag options. UDP responders may probe to discover the real MT value per destination. UDP responders should compose UDP responses that result in IP packets that do not exceed the pass MTU to the requester. Of course, as in the conventional case, a specified value, for example, 1220 or 1232 as the DNS packet size limit may be used. And in section 3.1, recommendations for UDP requesters. UDP requesters should send DNS responses with IP.flag, IPv6.flag options. UDP requesters should use the requester's payload size to limit the passMTU value minus the IP header length and UDP header length. And UDP requesters may drop fragmented DNS UDP responses without IP reassembly to avoid cache poisoning attacks. Next slide, please. Please review and comment. And there are my idea to update. I will discuss with co-author and we will submit next version as soon as possible. I'd like to add text to avoid packet loss at UDP responder. I'd like to add text. If the UDP responder detects immediate error that the UDP packet cannot be sent beyond the PassMQ size, e-message size, the UDP responder may recreate response packets fit in PassMQ size or TCBit set. And I'd like to change priority. First, IP don't flag. Second, avoid packet draw. Then I'd like to add text in introduction. This document proposes to set IP don't flag, IPv6 don't flag in DNS UDP responses in order to avoid IP fragmentation and describes how to avoid packet losses due to IP don't flag, IPv6 don't flag. And I'd like to change order. First, section 3.3 recommendations for responders, and second, recommendations for requesters. Yes. Thank you, that's all.
Thank you, Fujiwara-san. And any comments on this? This document feels like it's been through a great deal of discussion and good solid work in the working group. So curious where people think it's at. Warren, was that an old hand? Go ahead, Mark. You may be muted. Still not hearing Mark.
It just it asks for permission after
There
I give
you
it
are.
permission. What the? Anyway, this document doesn't talk about TSIG at all in terms of recovery and how to behave when you're using TSIG, because TSIG completely prevents reassembly attacks succeeding. One has there's a different need in terms of whether you allow fragmentation to occur or not when you're sending a TSIG reply. The TSIG replies, you can fragment as much as you want, and there's no reassembly attack that can successfully deliver a DNS packet, DNS UDP packet, which we misinterpreted. I do have the well-known draft, which we also, as a way of making, as a way of extending DNS without having requiring DNSSEC to prevent off-path attacks, including off-path reassembly attacks succeeding. So this document should, at the very minimum, take into consideration TSIG signed responses to TSIG signed requests in a different manner to non-TSIG signed requests. Does that make sense?
Do you mean your well-known TSIG key idea?
TSIG prevents reassembly attacks. It also prevents referrals being off-path off-path spoofing of referrals succeeding, providing both sides of the communication doing TSIG. At the moment, this draft does not use the word TSIG at all anywhere in it, and the way you reply to a TSIG message should be different to the way you reply to a non-TSIG message.
I think well-known your well-known TCP idea is another good idea, and fragmented avoidance is different.
Yeah, but they interact with one another.
Yeah.
Because if you're dealing only with plain UDP and no crypto over the top of it, you have a different problem space than UDP with crypto over the top of it.
Mark, can you suggest text maybe to the list?
I can try. You would have also seen, I presume you also saw my call for adoption of the other, the well-known one, Suzanne. But yeah, I'll leave that with the chairs for that one.
Okay. And who was next, Tim? Ralph, I guess, was next.
Yes, hello, Ralph Weber Akamai. So TSIG queries are only a small part of sort of the overall DNS traffic, and I don't think that we'll see more adoption. But the other main problem is that fragmentation within IPv6 is, from what I've heard, just not working. So rather than to kind of make one additional kind of special use case, yeah, we can do fragmentation with TSIG over v4, but we can't do it over v6. I think what Fujiwara proposed is much better. I mean, have a clear guidance. If you want to run DNS, you don't fragment, period. End of story.
I keep hearing that fragmentation over IPv6 doesn't work. But if you turn off your local file, if you actually let fragments through your local firewall, they get delivered. They get delivered reliably. And IPv6 is still very much in an early adopter stage, where people are still paranoid, really paranoid. IPv6 has a 32-bit fragmentation reassembly ID, which was designed specifically to defeat fragmentation reassembly attacks. I find it absolutely ludicrous that we can't send fragments over IPv6. We're saying don't send fragments over IPv6 when IPv6 is designed to avoid the attacks, but send fragments.
But because of other gotchas in the protocol, like extension headers, nobody's actually paying attention. So everybody has their firewalls turned off to, well, drop fragments.
There's a difference between a fragment and an extension header and a fragmentation header. There really is a difference, and people keep lumping the two things together when they are absolutely different. People do studies to say reassembly extensions don't work, and that's it ends up being a self-fulfilling prophecy. If you don't send them, they won't work.
Well, again, people tried and it didn't work.
If you actually send said fragments through the core of the network as responses. They get there if you let them in.
Okay, I think this sounds like it needs to go to the list and be sort of worked out there, but I appreciate the energy going on there. So let's say we move on to Peter and then close the queue after Joe.
Well, this is Peter van Dijk at Power DNS. Over the last 2 years, several, but not all DNS vendors have come together to somewhat solve the fragmentation problem as well by agreeing on a default buff size in our configurations of 1232 bytes. This document plainly states that that was wrong. I think that that is divisive, and I do not think that that text belongs in an RFC.
Thanks, Peter.
Thank you.
Mr. Joe?
I put my hand up just as you said that the fragmentation conversation should go to the list. So I will talk there.
Okay. There's lots of moving parts in that fragmentation discussion, so I think it needs to be fleshed out in text. So thanks all. And thank you, Mr. Fujiwara-san. So we will continue on this one and hopefully sort of get to some more consensus.
Yes. Thank you.
Yep. I believe it's Manu up next.
I believe, no, that's not the one. We've already been through that one. IANA considerations. I believe that's Mr. Hoffman.
Yes, it is. I'm sorry. Yeah, sorry, Manu. I was looking at my list incorrectly. Thank you. Go ahead, Mr. Paul. And you're muted.
Still can't hear you, sir. All right.
Can you hear me now?
Yes.
Yes.
Okay.
Let's try.
Thank you very much.
Turn it off and turn it on again. Okay.
Yeah.
So this document, which is proposed for the working group, is just one very small change, and it is motivated by Dimitri's talk earlier. So next slide. Right now we have Dimitri's document that you talked about earlier, which has to be on standards track currently because the algorithms for DS are stated as being standard required. And we're going to have a bunch more of these coming in the future with post-quantum signature algorithms. And when I say a bunch, I believe we'll probably have 3 or 4 at least as people try this one, try that one, and such like that. And we don't need to have this problem. Other IETF working groups have all of their algorithms done either by expert review or just RFC required. So an informational RFC is okay. And if you look in this document, you will see that that we just forgot with DS and NSEC3 records. You know, we actually made everything else for DNSSEC be RFC required. But we didn't do it for DS records because we weren't updating that. Next slide. Thanks. So, like I said earlier, the working group actually looked at this in 2010 with RFC 6014, and we made all of the DNSSEC registries RFC required, meaning it could be an informational RFC, doesn't have to come through the working group. And we forgot DS records and then SEC3. So the current draft simply makes DS records and NSEC3 be just RFC required. And again, this would make it easier for people to get what they want and faster without without us having to spend a lot of time on it. Next slide. So to backtrack, there are 3 things that we could choose, which different working groups choose for algorithm assignment. We can have standard requirement, which is what we currently have for DS records, which also must have a full IETF review, which of course takes a lot longer. And anytime anyone wants one of these for a DNSSEC DS record, it's going to probably have to come to Dnsop. That is, it would not be able to start with an AD. Or it could be RFC required, which can be done through the independent series editor, which doesn't require an IETF review, although the ISG gets to preview it. Those still can come through Dnsop. So if someone is saying, I want an RFC, and it comes to Dnsop, that's fine. It's just RFC required doesn't have to come through Dnsop and go through the IETF. It can go through the ISE. Or just specification required, which is any external document. It could be a particular version of Internet Draft. It can be an RFC. So RFCs, are there. With specification required for like DS records, it's not like that anyone can get whatever they want. It will definitely have an expert review. So it's not like we're giving them out like candy. And as we've seen for many of the other things that DNSOP has done, expert review is completely sufficient for fixing things that people want and yet still getting them the code points that they really want. Next slide. So just to be clear, if we said expert review, not even RFC required, but just expert review, the experts actually are assigned by the ISG. So it's not just that someone says, I'm an expert. Someone has to agree that they're an expert. And the ISG can replace experts. So if an expert sort of goes rogue, they're going too slowly, they're being too conservative, they're being too liberal. Oops, I dropped an O there. The ISG can replace them and does replace them at times. So, it's not going to be like that we're going to have an inherently polluted registry if we just go with expert review. So, and anytime an expert makes a decision, especially against a code point request, decisions can be appealed to the ISG. They are often. The ISG sometimes overturns experts, often doesn't. So really what we in DNSOP need to decide is, do we want to do things with a standard required, or do we want to do things like TLS and IPsec and SMIME, which are mostly going towards specification required with expert review. And as far as I know, none of them have had any actual problems with that. None of them have gotten their registries polluted with junk or anything like that. But that's what the working group has to decide. Last slide. Thanks. So here are the possible next steps. One is do nothing, that is, don't adopt this draft, at which point then the GOST signing still has to be a standard, which means it would have to go through working group last call and then followed by IETF last call. It might have to come back to the working group if there are questions, such like that. And if we do nothing, then in a few years when we get all of the post-quantum signature algorithms, then we're going to have to, all of them will have to come through the working group. We can adopt this, this draft and choose RFC required, which is what is in the current draft. So if we do that, then Dimitri can just, keep moving his draft forward in the working group, but as an informational RFC. And that would match basically all of the national crypto RFCs in the IETF, except for GOST for DNSSEC, which we did the last time, and we also made a standard. But basically, if you look at the national crypto for Asian countries, for other things for GOST, they're all just informational, and I think they should be. or we can adopt this document and then choose specification required. Again, at which point Dimitri could move his document through here as an informational RFC. He can take it out of the working group, whatever. I bet that he'll leave it here because we're almost done with it. But then that would also mean that when future ones come, for either RFC required or specification required, they don't have to come to the working group. They can if we want to pull them in. So that's my last slide, and it's up to the working group and the chairs to decide what they want to do for the next steps.
Thanks, Paul. I remember the last time you brought this up, we had some issues raised by some of the implementers about, you know, how do we give guidance on to the implementers and stuff, and that's where I kind of like to hear if any of the implementers like to speak up and sort of say their piece. They were the ones that had, you know, good arguments, like how do we sort of give guidance, you know, in the registry as well as the things that we should implement versus not, and maybe we fix the registry to sort of give better guidance that way as well, right?
Well, we've already done that. We already have the should, you know, the should be implemented, not implemented. Yeah. We already passed that, and so this would tie right into that.
Yeah.
But again, I certainly, yeah, I am not an implementer, and I don't have to deal with this, and I don't have to deal with, you know, the stuff that's coming down the line with post quantum either, which will be probably a lot more painful.
Okay. Oh, Lars.
We can barely hear you, Limon.
Yeah, you're very faint.
All right, let me see what I can do about that.
We can't actually hear your words. I just recognize your voice.
All right, let me look at my settings and get back.
Okay. Any others that would like to speak up?
Okay. Ruman, you want to try again?
Yeah. Well,
I don't have any problems with any other, you know.
We can still barely hear you, Limon. But we can see you now.
Let's go to others in the queue and we can try again.
Yep,
Dimitri. Thank you.
I'm fond of the idea of relaxing the requirements in whole. But anyway, I'm not sure that changing the process for the draft that was already adopted by the working group is the best possible solution. That's all.
Mark?
I think RFC required is the way to go with this sort of stuff. Invariably, specification required, the specifications disappear. They're not stable. At least with an RFC, we've got something we can always come back to. Specifications just disappear on us. I've seen that happen too many times.
Yeah. So, Jim?
I have to say I sort of disagree with Mark about going down the RFC required route. My preference would be use an expert review, but of course we need some kind of document to specify the standard, and that needs to be documented for a new crypto algorithm. But I think something lightweight and pragmatic is the way forward here. Requiring an RFC for every single crypto algorithm that might be possibly used for DNSSEC seems overkill to me.
So some working groups or some other protocols have done just fine with specification required, and the references don't disappear. But, and I will say this, having been SMIME working group chair, we actually did have one of ours disappear. But as someone noted, no one gave a whatever about it anyway. So it really just made it easier for implementers to say, I didn't want to implement that the first time and rip it out. So Mark is correct that they can disappear, but basically nothing important ever has.
Yeah, I mean, I think we should fall in line with what other working groups are doing for this similar kind of stuff. That seems to be the most sensible thing to do here.
Yep.
Cheers.
Okay, thanks, Jim. And Paul, I think in Dimitri's case, in either way, if he can get if a code point can be assigned sooner rather than later, while we sort of, if we go and put this up for adoption and it gets adopted and we kind of work through it and stuff, that may also keep things moving along for him as well.
So yes, that's true, Tim. But then we would have to have the discussion of whether this working group actually wants to standardize a new signature algorithm that is less secure than the last one that we standardized.
That's true. Yeah.
That is that the GOS stuff has the same security properties as P256, which is worse than EDDSA. So I would find that to be a weird backstep on our part that would need to be discussed. So I'm not sure that it's actually going to speed anything up.
Okay, that's good. Okay, just throwing it out there. Liman, you like to try this again?
Yeah, I would like to. Can you hear me better now?
Terrific. Yes. Thank you.
Thank you. I had to log out and back in again. So the thing I would like to bring forward here, that I see a distinction between two types of records. One is that requires special processing in the servers. I would call them structure carrying records. These will be like NS records and DNSSEC related records. And then you have the data carrying records, which are the things that applications actually look for, address records, SRV records, and what have you. And I think we might want to make a distinction between the two. So I would argue that for RFC specification for the structure carrying records, which require special processing, and expert review for those who just carry data, because they are handled differently by the software. So you might want to make that distinction. Thanks.
Okay. Thanks, Dimitri. And then Brian, and then we'll close the queue right after Brian. How's that? Go ahead, Dimitri.
I just want to clarify that the parameters that were selected for this algorithm seems to be not worse than EDDSA. They are based on the Edwards curve, Edwards form curve.
Okay, so I apologize.
I don't think that's... Sorry?
I apologize. I don't think that the word Edwards actually appeared in the RFC describing it. So I was assuming that you were using a standard prime curve with Weierstrasse format.
No. I deliberately selected the Edwards, the Edwards compatible one.
Okay, so then I take back what I said earlier, and they would probably have the equivalent properties of the last one we did.
Yeah.
Okay, thank you.
Thank you. Brian?
Specification and specifications disappearing. If something gets approved by an expert review, maybe do an informational after the fact, and maybe not do them individually, but maybe lump them together, maybe once every other IETF or something like that. Very lightweight, but at least that it ends as a informational RFC. Just a thought.
Okay, thanks. So
as to how every, so often every 1,000 or every couple hundred RFCs are summaries of the rest of the RFCs in a range of numbers.
Okay, thanks, Brian. Looks like Warren wants the last word.
I wanted to mention that we used to pull IDs out of the archive but now they're generally sort of kept around forever. So I think that if ID, if it's an ID, it kind of sticks around, and so that's relatively stable to me. Just my view.
Yeah.
Very happy. Blah, blah, blah.
Okay, thanks. So then
Great,
we'll
thanks.
probably,
So,
yep.
I look. You chairs figure out when you want to queue this. It sounds like there might be a time consideration given the GOST document as well, and happy to do it however you guys want.
Yep.
Thanks.
Sounds like a good plan. Thank you, Paul.
Yes, thank you very much, everybody. These peer process documents are not the most exciting things we work on, but they actually matter as far as getting technology and decisions into the hands of implementers and users. So thank you.
Hey, can you hear me?
Yes.
Yes.
All right, perfect. Cool. All right, so I'm Manu Bertel, and I'd like to talk about how we could share recursive resolver IP ranges and potentially also locations. Next slide, please. So why do we care about IP ranges or geolocation? So let's start with geolocation. Recursive resolvers may be distributed around the globe, at least the one from a given entity. And the authoritative servers on the other side may wish to actually serve geo-based answers. Some have been using the enetnum country attribute as an indicator of a country, but this is not really a very good signal or up to date. And also, like an IP range can be reassigned by an owner from a given location to another one, be it within the country to another country or whatnot. There is a bunch of existing GeoDB that exist, but they are not either the most accurate. Next slide, please. On the IP ranges front, resolvers are often a subset of a global organization IP pool, and people may want to use actually these IP ranges as a source to build network hackles or to build DDoS mitigation. As was mentioned by NetLab recently in their XDP post, talking to DNS operators at conferences, people are using response rate limiting. It works well for them, but they would like to be able to exclude some resolvers that comes from, relationship that they have prior. Next slide, please. So goal and non-goals. The goal here is mostly to provide a mechanism to have resolvers operator to share the IP ranges and geolocation, and a mechanism on the other side for auth operators or network policies makers to be able to get that data and to be able to consume it in a programmatic way. One of the non-goal is to be a real-time database that is accessed directly from let's say, authoritative server at query time. Next slide, please. So the current status, as far as I could get it, is a bit all over the place. There is no consistency in the location where people that share this information will put it. It may be a FAQ, it may be some API documentation. There is no consistency either in the medium used. Sometimes it's over HTTP, sometimes it's over DNS, sometimes it's over private email. And there is neither consistency in the format. It goes from a standard HTML web page to CSV or JSON. Next slide, please. So here the proposal will be to define a publication format that can be used globally, so people don't have to reinvent the wheel. They don't have to think about how they could present that information, and the consumers don't have to think hard about how they can easily consume that data. Some potential contenders, the good old TXT record that will be a space separated list of subnets, or a space separated list of tuples that contains subnet and the 2-letter country code. Or it could be a HTTPS record that returns a RAC 8805 geofeed. I think essentially there is two parts here. One is how to format it, the presentation of the data, and the other part is how to find that information. On the discovery side, this is maybe the hardest part. One idea was to essentially use a reserved underscore name that people could request, say underscore rdns.organization.com, and that will return either they will ask for the TXT or the HTTPS record, and that will return the data that they're looking for. Next slide, please. Some other ideas that have been mentioned to me. One is to use the IP range to basically use the inet null object to store this geofeed. This is actually now a working group item from the Ops AWG group. I've got a hard time to find how we could make it specific for resolvers. This is essentially the whole IP subnets versus just like the subset of resolvers. The original IFC 8805 draft was mentioning using name authority pointers. I didn't dig too much into it. I'm not very versed with the record itself. It seemed to be kind of complex, but I mean, for the sake of mentioning it here. And also people have been mentioning leveraging reverse lookups to find, given an IP request, let's say RDNS dot reverse lookup name TXT record to find this geofeed. Yeah, and I think that's it. The next slide is essentially hoping for questions, feedback. Oh yeah, open question maybe. Yeah, IFC 8805 has a notion of region, city, postal code, country, obviously. I'm actually wondering if IATAG code, 3-letter codes, will be a better mechanism to share location, because essentially that is what is widely used in general. TXT records can be abused, so we need to limit the size of them. And then UI versus HTTPS SVCD record, essentially the latter seems to be more flexible. Thanks.
Thank you. Benjamin?
Hi, Benchmark. Okay, I think I have 2, maybe 3 comments. The HTTPS record that you have as an example in section 3.2 is, I think, not a good choice. That's not really a good use of the HTTPS record. I'd be happy to work with you if you want to try to find a way to use service bindings for this. I think that we could talk about that. But I think that probably the URI record, like you mentioned, or the TXT record format is a better choice.
All right, cool. Thanks. Yeah.
The second thing I wanted to say was about the geocodes. I think that distributing the list of IP prefixes makes a certain amount of sense to me. That seems logical. The geocodes I'm pretty confused about. I don't understand why it would be the case that that the user geocode could be inferred from the observed recursive IP address. And I don't see why the location of the recursive resolver is of any interest.
Okay. Do you want me to reply to that, or I think you had a third question?
I think that's everything.
So I guess if we talk about user, then essentially we are in ECS territory,
yes,
which is a different thing. Here, the case is many people are building geo targeted answers, usually using some kind of GeoDB database. And they will say, oh, I'm getting this query coming from a resolver from that country. So I put it into that bucket and I'm going to return this specific answer to that specific location. At the moment,
So-
the GeoGB one is not the most granular, maybe, and not the most accurate.
So I guess I don't really understand the logic here. I can understand using geocoding for if there's some sort of country-specific service requirement. But it sounds like this is just about latency optimization, and in that case, I think that it's the end user location that matters, and it's the network topological location that matters. So I think that attempting to use the geocode is not as helpful as, for example, dynamically adjusting your responses based on latency measurements.
I totally agree with that. I just think that not many people can build those systems, or have built those systems that take into account latency versus geolocation as a geocode.
Sure. Overall, I guess my feeling is that the geocode thing is essentially labeling the wrong element, and if you think that that's worth pursuing, I would prefer to put that into an ECS-like tag as an eDNS element.
Okay.
Liman, and what we'll do, oh shoot, we'll close the queue after Alexander, but we're going to be running up against time here.
Running a little bit
Go ahead.
short, and there's some complicated discussions here that we'll go through the queue here, but also plan to reach the mailing list.
Yeah.
Thank you.
Okay, Liman here. I have two comments. The first one is that please, pretty please don't use the TXT record for this. The TXT record is not the kitchen sink for everything you can invent. So please invent a new record type. They are not expensive. My second issue is that I feel that you're conflating the resolver side with the authoritative side. You're asking the authoritative side to provide information about the resolver side, and these are, to me, completely disjunct. There's no chance that the name servers for NetNode where I work can provide information about my home resolver, and so how can I convey that information? So I would argue that a better place to put the information for the resolver is in the query going out from the resolver as an extra option in the eDNS or something along those lines. But I may be totally off the track of what you're trying to do, so I'll offer that as food for thought, but it might not be the right thing for you. But please don't use the TXT record. Thank you.
Lars, I think the idea here is to take collections of resolvers and move them and associate them with the country.
Yeah. Mark, Joe is going to be next, and then you, Mark. Sorry.
Yeah. I was just trying to clarify.
Okay. Mr. Joe.
Thank you, Tim. A little bit of context for people who are not familiar. I spent a few years at an enterprise DNS company. And while I was there, I learned many horrible things. And one of the things was, and the reason for ECS to exist is that the state of the art before ECS was to use exactly the address of the resolver that you see at the authority server in order to infer something about the location of an end user. And it's not a good heuristic. And that's why ECS existed. ECS also has problems. It's also not universally adopted. So this need to try and identify and locate exit addresses for resolvers, even though it's kind of horrible, is real. And there are lots and lots of queries that all of us do every day that depend on this in order to give us responses that match, a suitable local CDN cache. That means we can actually stream video that otherwise would come across an ocean. So it is real. And so one anecdotal piece of information that I heard from a resolver operator, it's quite a substantial one at a broadband ISP in the UK, who talked about how their resolver cluster basically had to be configured. There are 200 different exit addresses. And in software, they had to configure a different exit address for a query that was sent upstream to an authority server based on the IP address of the client. because they couldn't rely on Ethernet clients subnet existing. So it's an awful, horrible piles of hacks, but it's absolutely required in the real world. So I thought I'd just mention that. And one other comment as well about IATA codes. We discovered when we deployed LRoute that there's at least one country in Europe doesn't have any airports, doesn't have any IATA codes, and it was difficult to try and find a name to map that country in our naming scheme. So we ended up using low codes, which are based on postal addresses and not. They're kind of a combination of IATA codes and country codes. But anyway, look up low codes if you want to find something that works more reliably than IATA codes for naming a place.
All right, thanks.
Thanks. Mark?
When I was looking at this originally, looked at this first, I was thinking about APL records. They could definitely be extended by adding another family which contains the geocode itself. So there you've got both the IP address ranges and the mapping to the geocode. It would require defining a additional family, but I don't think that's an impossibility.
Okay.
All right, thanks. I had mentioned the APL in my GitHub repo, and I ruled it out because it seemed to be on v4, v6. But yeah, thank you.
Yep. Alexander?
Yes, thanks everyone. I agree with what Lehman has said. We shouldn't overload the TXT record, and actually there are two things that would make it would fall beautifully into place, because there is RS27553, the URI record, resource record, and there is RSC 5870 from yours truly, which is a geo URI type. Combining those would allow you to put the geographic coordinates into the DNS without overloading the TXT record. So Manu, if you might want to look into that if it is your case.
Okay. Thanks. And thank you. So we're on to our last talk, I believe.
Yep. Yes. There we are.
Hello. Can you hear me?
Yes.
Hello.
Hello.
Hey, I'll be presenting our draft updates to DNS access denied error page. So we have updated the draft to address several comments from the working group. Next slide, please. Yeah, I'll quickly go over the recap of the problem and then the comments that we received from the working group and the updates we did to the draft, and especially the updates we did to the security considerations to address the threat models that were discussed in the working group. Next slide, please. Okay, this draft is introduced because of the problem that DNS filtering is done for several reasons by various types of networks, for security reasons, for enforcing parental control, internal organizational security policies, and ISPs filtering because of the court orders or law enforcement agencies asking them to filter specific domains. Enterprise networks typically do DNS filtering to block malware and phishing types of domains. Home networks nowadays are offering very similar service, including parental control. A manufacturer user description, a recent standard which is quite adapted, discusses enhanced ACL to include domains, to whitelist specific domains to an IoT device, because IoT device, certain types of IoT device have specific purpose, and only certain domains they visit, and only those domains will be permitted. And ISPs nowadays offer malware filtering service and may block certain domains because of a court order. Next slide, please. Whenever any specific domain is filtered, the end user needs to know the reason why it's filtered. Probably a decade back, it was quite easy that many of the content providers were using HTTP, and there would be a HTTP server that would be deployed, and it would throw an error batch back to the user. But that changed with for good, that most of the content providers have now moved to HTTPS. But with that, the trouble is the end user will typically see a certificate error message and will probably click through those error messages to see the exact reason why it was blocked, and which could result in an MITM. The user does not know the exact reason why it's blocked, so the user may try to reach the domain several times, may switch to untrusted interfaces, and the user is eventually forced to install local root certificate and has to reinstall the certificate whenever it expires, which is cumbersome and error prone, and the local certificate could be used as an MITM for other purposes as well. Next slide, please. Dnsop extended error specification that was developed in this working group changes that for good. The blocked error codes, like censored and blocked error codes, do indicate some reason back to the user why access to that domain was blocked. But still, the exact reason because of which the domain was blocked. For example,
Hello? I think we lost audio from our presenter.
Yeah, it appears that we did.
Well, we can give him a moment to, it looks like he was kicked out, so let's give him a moment to attempt to reconnect. We may actually be about to run out of time.
Hello, can you hear me now?
There you are. Yes. Please
Hey,
continue.
sorry, my
Thank
meter
you.
code just crashed and restarted, so sorry for that. The exact reason because of which block, for example, if you see here, the categories because of which domain could be filtered could be quite different and could be vendor specific, and the reasons are also quite specific. And further, the user does not know which entity really blocked this domain, whether it's enterprise network or the ISP which blocked it, and whom to contact if it wants to raise a complaint. For example, if a domain is misclassified and blocked, and it is causing the user not to access those domains. And forged answers doesn't work, especially unless the endpoint is installed with local root certificates. Next slide, please. So the last session that we presented was using a HTTPS resource record type to convey the URI template for providing the error page. But then there was quite a good feedback from the working group that HTTPS resource record type was not the right resource record type to use, and was suggested to pick and use an EDNS option. So we changed the draft to use an error page EDNS option. So if you see, we have an URI template which will be conveyed in the EDNS option. I'll come and talk about in the next slides about the signature and the signature algorithm for their data origin authentication, especially to deal with the problems of an attacker injecting this URI, for example, to cause a phishing attack to the endpoint. Next slide, please. A simple example would be an URI. This is an URI that the DNS filtering server would provide, and the client, if let's say an access to example.com is blocked, then it would use a base64 URL encoding of example.com, would send this HTTPS URL to the server, HTTPS server, and get the reason, exact reason why access to that domain was being blocked. Next slide, please. Yeah, and this was a very important feedback that we got, that how do you handle error page URI injected by an on-path attacker. So for that, we have added a specific section to talk about the processing rules for processing these error URI EDNS option. There's several ones, so I'll list the most important ones, which is to say that encrypted DNS is mandatory for this to make sure an on-path attacker does not inject this error URI. Strict privacy profile is mandatory. If opportunistic privacy profile is used, which means that to say that either the client could fall back to clear text or may ignore the server certificate validation. In those cases, the error page URI has to be ignored. there has to be only one error page URI. There can never be more than one error page URI because it's the server which is filtering, and there is no need for it to provide multiple URI options. It could only provided when there is an extended error code which shows either it's insert, blocked, filtered, or forged. It has to only come with HTTPS URI scheme to avoid any attacker modifying the HTTPS response. And if let's say nowadays many browsers have pre-configured resolvers, and if they know that the pre-configured resolver does not perform filtering, then they can discard this URI option. Next slide, please. The other important change that we did to the draft was to add the data origin authentication, because it cannot be DNSSEC signed. So what we do is we basically, because TLS-based connection is mandatorily required either DOT or DOH, the signature is generated by using the private key of the encrypted DNS server, and the client, all that it has to do is use the DNS server's private public key to validate the signature, and it would know that this ADNS option is indeed coming from the DNS DOH or DOT server, and it is not coming from anybody else upstream. And it's pretty much that the signature algorithms that the client uses for TLS must match the signatures that it uses in the DNS client to validate these signatures. Next slide, please. Yeah, the last update was with regard to the security considerations to say that encrypted DNS is mandatory, data origin authentication is mandatory, and how do you handle with all the provisions in case if you're indeed talking to a malicious DOH server, how do you handle a phishing attack? In those cases, we followed the principles that a captive working group has taken, where the page would be loaded as an untrusted page. The client browser does not send any cookies, disables JavaScript, prevents any user interaction, does not autofill any credentials or autofills any personal information. A private browsing mode could be auto-enabled, and the error page could be loaded in an container isolated from other activity to prevent from malicious error URI pages. But we believe this would solve any corner cases of an endpoint using a malicious DOH or DOT server. Next slide, please.
Okay.
I think we have addressed all the comments received from the working group, and any further comments and suggestions are welcome. And we think the draft is ready for working group adoption. Any questions?
Okay. Thanks. It looks like we have a couple comments, and I think we only have a few minutes, so we can go through them. But Ben, you want to go ahead?
Sure. So thank you for addressing all those comments, and especially being thoughtful about the about having good tight restrictions on the use of the received web page. One thing you didn't mention, though, is that the extended DNS errors draft already has support for free text that will be shown to the user. So given all of the restrictions that you have imposed on the web page here, why is it important to have a web page as opposed to just making use of the extended DNS error code text?
Yeah. Thanks for the comment, Ben. So if you see the extended information option that we have in extended errors, it does not impose any of these errors. I mean, it could basically come from any attacker. So if you look at extended DNS error page option today, it just allows clear text DNS to throw those error options. But this makes it quite secure and throw a lot more details back to the user.
I think that those restrictions are interesting and perhaps could be or should be applied to use of the extended DNS error code text.
Sure.
But that doesn't really motivate the considerable complexity of going beyond that free text to a full web page, which then requires the extensive lockdown that you've had to enumerate. So I guess my feeling is that we should start by deploying EDE, by deploying it in browsers, but by seeing if there's appetite to actually display that the contents of that text field, and If there isn't, then I think there also won't be appetite to do more extensive and more complicated messaging in the way that you've described. The other thing I want to ask is, why is there a signature of this data tied to the TLS secret when the data itself is already being transferred over to that TLS connection? Seems
This
like
is
a
just
double
for handling a
signature.
scenario. Yeah, this is for handling a scenario where the ADNS option is being sent from upstream and the DNS server just forwards unknown ADNS options back to the client.
Okay, but in that case, what is the client validating if this isn't the server they thought they were talking to?
So this
Wouldn't they
is,
reject that signature?
yeah, with this signature they would reject that because it's not originating from the server it's talking to. For example, consider a DNS forwarder simply forwarding this option from an upstream server, and because the TLS connection is not established with the upstream one and the upstream server sends this option back, the DNS forwarder simply forwards it. The client would detect that it's not coming from the DNS forwarder it is talking to.
Okay, thank you. That's interesting.
Patrick?
We don't hear you, Patrick. All right. Technically, we're out of time for this slot. We can try to get through the rest of our queue here.
Patrick can't unmute. So Joe, we'll jump to Joe real quick.
I assume it's working. I'll just talk.
Yep.
I can hear you. Okay.
Like the requirement for encrypted secure transport was kind of an afterthought to deal with another issue, but fundamentally, like EDNS options are hop by hop. I don't see anything, maybe I missed it, I don't see anything in the draft that describes how, for example, a forwarder that receives a code like this from a resolver would then pass that back, and what signalings are available to do that, or whether there are chains of combinations of forwarders and resolvers. I think in general, outside of the narrow centralized .do type application, we don't expect end users to be talking directly to the resolver that would be doing the blocking. There's usually intermediaries. So I think it makes sense that this is not an issue that works with centralized DOH, but perhaps the draft could be more clear that this is only a solution for those environments and not a solution where there's something further upstream in the resolver graph that is actually doing the filtering and providing the signaling.
Yes, we'll make it more clear, but I think we have clearly made it in the draft that this is only suitable for deployments where the endpoints are discovering and using DOT-DOH service or are pre-configured to use the DOT-DOH service.
Okay, it's been a while. I'll read it again. Thanks.
Yeah.
Okay. Wes, while we wait for Patrick.
So just really quickly following up on, I think, Joe, and actually more, and to Ben, but also to the author in general, looking back at the discussion we had with EDE in the first place, when we discussed where the extra text field went in the past, we didn't really come to consensus on how it would ever be displayed to a user. In fact, I think the general consensus was, and it's even written in there, that it's for operators to take that and log it and do things. It's not intended for user display. So this draft significantly differs from that in many ways. And one of the reasons that, to highlight Joe, we did not come to a conclusion on, well, how do you deal with these forwarding and hopping kind of things, and how do you deal with messages that are crossing barriers. When you get into user space, then you get into internationalization concerns and everything else too. So this draft is significantly different in EDE in that way, and there be dragons at the same time. Good luck. Good dragon.
Hey, thanks. Yeah.
Fair point. I think that definitely gets us to the end of our agenda, and I believe the end of our time slot. We have another slot Friday morning, yep. Thursday night U.S. and North American time. So we will look forward to seeing folks.
Everybody then. Thank you all. Yes. And we will close this out.
We are done for now, and thank you very much for your participation. And that's a wrap. Okay.